Hey, welcome back to Made Up of Wires, where we're decompiling Castlevania Symphony of the Night. You can go to sutton.z.dev to learn more about this project. And one of the requests that was made last week was to go over some of the changes that have happened recently in the project. And of course, I didn't prepare for that. So we'll do it. We'll do it live. You can find a link to GitHub. And from there, we can go look at the commits and see what has happened in the last couple days. Let's go back about a week or so, and we'll start at the beginning of the year. There hasn't been much yet. I think things have slowed down quite a bit. Mephisto is a name I'm not familiar with, so new contributor, or maybe one whose name I don't recognize. Cinemax doing a lot with music IDs and other documentation. Really appreciate it. So let's go from the bottom up. Pick out the ones that I think are interesting, and then if there's any that anybody wants to look at, like, comment, subscribe, and I'll take a look at them for you. All right, paths for assets, which I've begun importing. Let's take a look at that. That I'm guessing has to do with the assets tool, which is specific for Symphony of the Night. We have ways to extract assets and convert them into forms that will make them easier for us to compile and integrate later on. Some renaming of the Red Door entity extension. Fields, bunch of them by Mephisto. Let's take a look at some of those, since I'm not familiar with the stuff that he's worked on. See what those look like. A bunch of work on the reverse catacombs by Josh. Getting some DSS symbols imported. That's nice. And then eLife. Eldritch, nice to have you back. This should be something like 68 renames in total. Yeah, anytime the entity extensions get updated, it has, especially with the bottom 10, or sorry, bottom 15, it has a possibility of affecting quite a bit. So the assets tool, I'm not sure how I feel necessarily about the assets tool, but it is something that we use for extracting assets. And I mostly think about my concerns about it, and I haven't really talked about it too much, but my concerns about it are, one day, should we have, say, a way to port the game to other platforms? Legally, you're going to need a copy of the game, your own copy of the game, to still play that port. And so it would be nice if we had some runtime way of saying where different assets were on the disk and being able to pull those and convert those into a form that could be used for modern tooling. So they could be bitmaps, they could be whatever, some way to pull those from the disk and put them at specific locations in memory. Typically, I think that's the way I would go about it. And what our assets tool does instead is takes those and extracts them to disk, and usually formats them as different C files that then need a compiler. And I think that's fine for doing the matching decomp portions, but I'm not sure how yet that will work when we get to a point where maybe we want to make this easy to run on non-PlayStation systems using the original discs. And maybe that's just a goal that I have, but I think that would be a good to have. So I'm not sure yet how those things interact. The tool is written in Go, which doesn't necessarily have the best foreign function interface for calling into that code to be able to use in some other application. So that could be a concern. And then the thing that I think from a development loop standpoint that I don't necessarily like is that for each version of the game, assets for every overlay are included in the same file. So that means regardless of which overlay you are modifying or adding configuration for, once you change that file, every other asset that's configured in there has to be re-extracted, which then causes everything downstream to have to be recompiled as well. And so you end up with a situation where changing say a brand new overlay with maybe a dozen files ends up resulting in several hundred files having to be recompiled. And usually I just don't like how systems like that work. So I'd rather have more granular configuration. So those are my issues. But what it does allow us to do is it's a significantly faster tool than what we previously were doing with Splat plugins. So Splat allows you to define certain sections using a plugin interface where that plugin can then extract that data any way which it chooses. The problems are Splat is written in Python, and usually the plugins are as well, and Python is just slow. And so having to find the plugin location, execute the plugins, and things like that was just adding a significant amount of time for the build, and the assets tool is significantly faster than that. That's kind of a recurring theme with a lot of the decomp tools, and I don't know how other projects are doing it. My general feeling has been with the N64 projects, they have a single binary that they're decompiling, and the amount of things that they have to worry about is relatively small, and we're up to over 3,000 compilation units at the moment, and so the complexity is just, I think, much higher than other things. So this is adding some configuration here. This seems like something that we could almost pre-bake and configure this type of thing for all of the overlays that we plan on targeting. And that might be something worth looking into. Maybe they are. So we have RPO 7 and 8 already in there. Okay, so all the overlays are there, they just don't have this particular config. That seems like something that could be automated, and maybe, or just done and finished. So that's what that is. Renaming these fields. Beautiful render of the save. What is that? A hexahedron? Let's look at those. Nice to have good naming here. This syntax, if you're not familiar with it, if you're not familiar with C, this is called a bit field, where you give the type can be used as a normal C integer type, but we're going to say within this struct, only use this many bits for it. In this case, it's a 16-bit data type, and we're saying use 16 bits for it. So what's going on there? You can't just specify a type without a name unless you're using a bit field, in which case you can. And so this lets you put padding in a struct and keep that padding anonymous, which means it's not addressable, which means you can't accidentally write unknown 82 somewhere and get some programming error. So mostly it's just a way to take up space. I think I like it as an idiom. And fortunately, it looks like most of the Red Door stuff is shared. So while it is reused all over the place, the amount of code itself doesn't have to change too much. So that's pretty nice. And what else do we have? Like I said, shared life up. That's good. I need to get my changes in because it looks like Josh is working here in NZ1 as well. And let's see what new music IDs we have. That might be interesting. Oh, and very nice. So we have an enum now. I'm guessing probably an enum with all of the music names to fill in this table. That's awesome. Eldritch is in the chat. Eldritch has a great spreadsheet of all of the weapon attributes, and I started making a table like this for weapon attributes. It's just so huge. I don't know what the best way to do it is, but basically I need 1,000 columns across to get a nice table layout. I don't know what if anything we'll ever do with that, but always good to improve readability and get rid of constants with named data. So I think what I'm going to do is look at Fleeman. So I mentioned Fleeman has some differences from the shared Fleeman. I want to see where those differences are. We're looking at Clock Tower specifically. Fleeman didn't match. Let's look at Fleeman specifically. It might just be Flea Armor. So there's a few things here that I want to look at. So we do have a shared Fleeman and even a shared Flea Armor, but one or more of these things aren't matching up, and so we need to determine why. We have a duplicates report that we can look at that does fuzzy matching on duplicates, and so we can look to see whether or not, for example, check field collision Y, if that matches. So that does look like it is, that one is identical. Entity Fleeman, that one does look identical as well, and then change direction, or update facing direction, let's look at that. It's right down below. That one looks identical too, so I'm not sure why. It may be that no one's done the work yet to map this, but we should be able to map this one, I think. It didn't look like anything was different, so that means Flea Armor must be the different one. Now, I've flipped the side of which one. Flea Armor is the same, so that one is the same as well. So why aren't these matched? There must be something going on. Otherwise, I feel like somebody would have done the work. Let's look at that Flea Armor again. So late in November, Josh did get this to match. Let's look at that commit and see if there was anything that needed to be shared or changed in Flea Armor. I don't see anything obvious. Here it is. Okay, so this basically a dead check. Was the difference. Okay, so it looks like Fleeman's the same. We could do a couple things. We could just assume that it's the same and see if it works. We do need a few things. So there's this one ACC that may or may not be defined already. in which case we would have to define it. And then the initialization code as well. Or initialization data. So let's do these two first. They should be relatively straightforward. And if they're the same, we won't have any problems. And that worked fine. And as I'm assuming that this is not going to have any external dependencies. Looks like not. All right, that worked fine as well. And so I'm going to do the same thing with the PSP. Well, I'm going to try to do is get this to kind of converge with the shared Fleaman, and then once it does, we should be able to share that code. So I'm going to do the same things over here. I don't think well, let's see if I can make it static. I'm not sure if I can or not. Those worked fine. And so now the tricky one is entity Fleaman. We just need to see where the data is that we're going to need. We could do this a couple different ways. I'm going to grab the splat config, see where the data for Fleaman is. It looks like it's mapped already. I'm going to check to see whether or not it looks the same. So we have there's a couple of annoying things. It looks like the best option may be to map the symbols first and then bring in the data. If we don't map the symbols, we can't reference them from the assembly. And we could, let's keep the symbols the same for the moment. What we don't have is this ACC. We'll have to figure out what that is. So I'm going to assume that this data is going to be the same. It looks like at least the first couple of values appear to be the same. And down at the bottom, I'm not as sure about. We have the 4, 0, -8, 0. So it looks like sensors move X is not there, or more likely we're ending too early. I think that's what's happening. So let's map what we have here. I'm going to comment out these names. And put the names that we currently have. And what I think we're going to see is that last value isn't there. So I mentioned a couple weeks ago that I started this other project called SciK, which is a tool for reading SciQ, lib, and object files. And it's, I think in general, it went pretty well. But now, so it is a modern implementation of dump obj and, oh, we're missing the bottom two. We're actually missing, it looks like a little more than that. Or this data is not complete. Or the bounds are wrong. Maybe the bounds are wrong. Let's check it and see. A fixed value is a 1616 real number. It means 16 bits are used for the integer portion, 16 bits are used for the fractional portion. So we can look at the top 16 bits. The fractional portion is all 0, so we don't have to worry about that. This is a -2, and that's what we have over here, fixed -2. So the important part is, does this go through -2.5? And it does. And the top goes -0.5 to -4, and that's the same. The next ones we have, it looks like bytes, and so those are going to be in, if we look at this over here, they're going to be in little endian order. The SPIM, when it's disassembling, corrects the little endian. It thinks it's a word, and so it flips all the bytes around, so we can go use this field here. This is the order they are in memory. So we should have 4, 16, 4, 17, and that's what we have. And then 4, 18, 4, 19, yes, and then zeros, okay. Here we should have 10, 0 in opposite order, and then 0 and 4, yes. 6 and -4, yeah. -12 and 0, okay, so that one matches, that 9C. Oh, I missed it. I gave it the wrong, that's where the issue was. I gave it the wrong name. 1, 2, 4. So I think we're just missing, what, 1, 2 words of data. Yep. All right, so let's look at the next one down, which is going to be 22B8. And my guess is we're going to have, this is going to be just in 16-bit little endian, but -9, 6, 0, -12. So what we should see is what? 9 is -7. Difference. So F7. And then 0006. Zeros, and -12 is going to be FFF4. Let's see if I'm right. Yeah, I was right. And really, there's no reason for that section to be there. So we can just get rid of that, and we should be good. So I have to find all this, and that data was the same, which is great. What I want to do is just make sure that is correct. And this looks like it's going to end up being relatively straightforward. So we've moved this into the C file, so we're going to just make this a dot. And I'm not sure what the problem was, so let's try it again. I'm going to make without that. Did we get any warnings or errors? We didn't. So somewhere in here, the amount of data that we have is not quite right. So let's look at the eFleeman data. It's possible that we have an extra byte of padding, or extra word of padding here. Let's look at eFleeman and see what sensors move. Why was the other thing that may or may not be happening is that these are static and they shouldn't be. It's possible that there's padding here. So I'm going to take out the statics first, and then we'll see if there's something else. No, still an issue. Okay, so unfortunately that didn't quite work. What we do have, though, is enough information to make this name all these symbols. And so let's do that, and then we can see if we could pull in the other code. I think that's probably the best. Do they line up? I think that they do. Hey, Roman, good to have you. They are similar enough that I figure that they were the same as the ones in the shared file. And I could be wrong, and maybe that's where I've gone wrong, is by relying on those. I could pull in the data from the assembly file, and maybe that would tell us something. But I'll map these first and see if the code works. And assuming the code works, then that might tell us something else. I do need to figure out where that other var is if we need it. Oops, that's not what I wanted. Well, anyway, so I was working on this, been working on this SciQ project, and I decided the reason I wanted to do it was to be able to read the SDK libraries and compute fingerprints for them to make them easier to search for in projects without needing to have those libraries, because those may or may not be hard to come by. And oops. Oh, no, don't go. I got to the point where I can get all the, well, I can read all those files, that's fine, no issue there. But then I need to pull out the text code segments and be able to write hashes to them, or write hashes for them. And let's make sure that that is what I expect it to be. Eventually you get to the point where you get to all the relocations, and you have to basically start mapping symbols into different sections. And I realized I am probably going to be writing a linker. So I think I'm writing a linker now by accident. And so I wasn't planning on rewriting SciLink, which was the SciQ or PlayStation linker. But I may end up doing that. We'll see. This padding here may ultimately be the issue. Let's see if that... I have all the bars mapped. Let's try that. Get rid of that last var. And maybe there's some phantom variable in the next segment. I don't know. Exactly. Roaming says, everyone falls down that rabbit hole. One day you're learning assembly, and the next you're writing a JIT compiler. And I found that actually several times when writing assembly back in the college days to now. Like you're looking at machine code or you're looking at assembly, and we had some assignment where I think we had to convert our assembly into, just by hand, convert it into binary. And I thought, why wouldn't I just write an assembler to do this? And I probably should have. I don't think I ended up writing an assembler at that point, but that seems like it would have been the way to go. So this is an odd place to put the data, but I'm going to do that. And I got rid of the wrong variable names. So it looks like there's some padding here. I'm going to exclude the padding from this. It makes it seem like maybe there's some zeros at the end of this that aren't accounted for in other overlays. Not sure. Or it could be that the data is actually different and I've just overlooked that. I'm not the best at noticing subtle differences. So maybe that's the problem. So let's try this and see if this works. Yeah, it did. That's weird. So there's 4 bytes that just fall off the end of this that don't seem to be associated with anything. The Medusa so let's do the same thing with PSP version. Now that we have all that data in, I could actually go. We're not lib, so we don't need this variable. I'm going to move this down closer to this. I guess I could keep it up where it was. I usually like having any references close to the functions that use them. So we're not going to use that. So we probably have enough now. I don't know if init fleeman is defined, but we'll find out. Unused data is not stripped in the PS1. It is stripped. If it's static, it is stripped from the PSP. So we need to figure out where this init fleeman is. And we can look at the assembly to do that. So we're going to look for an initialize entity function. So we look for the JAL instruction, calling initialize entity. Oh, that's probably more than one space. Yeah, there we go. And what is being passed to that? We look at the A0 register. That's the first argument passed to the function. And this is it here. So we can rename this init to einit fleeman. And we need to see, I guess, if this was used anywhere else. So we have it in EINIT. So we don't actually need it in the symbol table, but we do need it in EINIT. All right, so this was all identical after we got rid of that padding, which means we can just use Fleaman. And that works. And so we should be able to do the same. We need to do the, we don't need to do all of the mapping, or shouldn't anyway. Hopefully. We will need to make sure that these bars still work. We might have broken the PSP by doing that. Yep, we did. And so we have to fix the PSP, and the easiest way to fix the PSP probably is to just go straight to the shared version of Fleaman. It looks like this data is ending appropriate. Let's make sure that's the case, since the other one wasn't. Oh, weird. This one is ending in the appropriate place, so that extra padding is odd. We should go back to the PlayStation and see if anything is in between Fleaman and the Medusa head spawner. If so, it looks like there's probably an additional variable there. An additional word that's being explicitly set to 0. That would show up in BSS unless it's not being used on the PSP. We may or may not be able to find it. So I think that should be fine. Yeah, that works for the PSP as well. Let's go do that. So I had to over here. So in the Splat config, usually we have pretty clear separation between different segments for these in the different compilation units, and they're usually stacked right next to each other. We might not have named them yet, but usually they're there's not just 4 random padding bytes in the middle of nothing. So we need to figure out where those are coming from and why they're there. The way that this is now, this is gonna compile fine, and we're gonna get a matching compilation. We don't, if nothing is using this data, that's the other thing, we could see if something's using it. But if nothing's using it, then we could just ignore it and move on with our lives, and that's probably what we should do. But I like to figure out what's going on. So let's see. First, we're going to see if anything references that at all. Usually that's why a label exists. In this case, there wasn't a label here, though, so unlikely that anything is going to be referencing this. Yeah, so we just have the references to it in data itself. And so then the other thing we can look at is when we're looking at RO data or text or BSS, does anything exist between Fleaman and Medusa head spawner? So we'll start at the top. That gets us to data because that is where things start. RO data, there's nothing between there. And then for C, there's nothing between there either. Let's look at Medusa head spawner. It could actually be part of that. But that is just including a common file. I'm going to open a new tab with this, and we'll look at that common file and see if there's like an ifdef or something before that. No, I don't see anything. So we could throw a sign32, a static sign32 in here, and that would probably compile fine and allow us to get rid of the gap. But I don't know that it's an improvement either way. This is nice and doesn't have anything else in there. So that one was pretty straightforward. I actually thought that there was something different between the two, but it turned out that there's just a small amount of library code that differed between the two overlays. So we can get rid of the PSPE Fleaman. And that's one of the hopes along this whole process is we think that the code is 99-ish% the same between the versions of the game. And so by the end of importing this overlay or decompiling this overlay, we should have nothing left in this section. Let's look at some of these and see what's left. I thought we worked on background gears, but I guess never got a match, or did we? Let's see. Could be that I forgot to get rid of it. No, it's still there. Okay, so there's more work to be done here, but we did get the Fleaman stuff figured out. So I think that's where I'm going to leave it today. Short stream. Other things to do. Appreciate everybody showing up. Roaming, Eldridge, good to have you back. Go to sutton.z.dev to learn more, and we'll be back doing some decompilation tomorrow. Click the button too fast. Adios.